This section provides information about using load balancers as part of securing your infrastructure. The Elastic Load Balancing, or ELB, service automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, and IP addresses. You configure your load balancer to accept incoming traffic by specifying one or more listeners. A listener is a process that checks for connection requests. ELB scales your load balancing device as traffic to your applications changes over time and can scale to the vast majority of workloads automatically. This increases the availability and fault tolerance of your applications. You can add and remove instances from your load balancer as your needs change without disrupting the overall flow of requests to your application. ELB can handle the varying load of your application traffic in a single availability zone or across multiple availability zones. You can also configure health checks, which monitor the health of registered targets. With health checks in place, the load balancing device can send requests to only healthy targets. When the load balancer detects an unhealthy target, it stops routing traffic to that target. The load balancer resumes routing traffic to that target after detecting that the target is healthy again. ELB is integrated with other popular AWS services, such as Amazon EC2 Autoscaling, Amazon Elastic Container Service, or Amazon ECS, AWS CloudFormation, and AWS Certificate Manager, or ACM. ELB supports three types of load balancers: application, network, and classic. An application load balancer operates at the request level and routes traffic to targets such as EC2 instances, containers, IP addresses, and AWS Lambda functions based on the content of the request. It's ideal for advanced load balancing of HTTP and HTTPS traffic. This type of load balancer provides advanced request routing targeted at delivery of modern application architectures, including microservices and container-based applications. An application load balancer simplifies and improves the security of your application by ensuring that the latest SSL and TLS ciphers and protocols are used at all times. A network load balancer operates at the connection level and routes connections to targets such as EC2 instances, microservices, and containers within a VPC based on IP protocol data. It's ideal for load balancing both TCP and UDP traffic. This type of load balancer is capable of handling millions of requests per second while maintaining ultra-low latencies. A network load balancer is optimized to handle sudden and volatile traffic patterns while using a single static IP address per availability zone. A classic load balancer provides basic load balancing across multiple EC2 instances and operates at both the request level and connection level. A classic load balancer is intended for applications that are built within the EC2 classic network. How is data protected in ELB? First, a load balancer serves as a single point of contact for clients. The load balancer distributes incoming application traffic across multiple targets in the multiple availability zones. This increases the availability of your application. An application load balancer can sustain secure HTTPS communication and certificates for communications with clients. You can optionally terminate the SSL connection at the load balancer level so that you don't need to handle certificates in your own application. Second, if you enable server-side encryption with Amazon S3 Managed Encryption Keys, also known as SSE S3, for your S3 bucket for ELB access logs, the ELB service automatically encrypts each access log file before storing in your bucket. ELB also decrypts the access log files when you access them. Each log file is encrypted with a unique key, which is itself encrypted with a key that's regularly rotated. And third, ELB simplifies the process of building secure web applications by terminating HTTPS and TLS traffic from clients at the load balancer. The load balancer performs the work of encrypting and decrypting the traffic instead of requiring each EC2 instance to handle the work for TLS termination. This diagram shows how load balancers work. This VPC has subnets in 2 availability zones. Each availability zone has a public subnet and multiple private subnets. Internet traffic goes from an internet gateway to each availability zone. A load balancer in each public subnet directs traffic to web servers in a private subnet in either availability zone. Traffic from the web servers goes to a load balancer, which directs the traffic to application servers in another private subnet in either availability zone. Traffic from the application servers goes to the primary database server in another private subnet in the first availability zone. And the primary database can communicate with the standby database server in a private subnet in the second availability zone. Here are the key takeaways for this section of the module. ELB automatically distributes incoming application traffic across multiple targets, such as EC2 instances, containers, IP addresses, and Lambda functions. ELB can handle the varying load of your application traffic in a single availability zone or across multiple availability zones. And finally, you can add and remove instances from your load balancer as your needs change without disrupting the overall flow of requests to your application. Thanks for watching.